One of the first questions I have is, what does a chemist do?
Ooh, that's a great question. We're surrounded by jobs that chemists do, and how to repair potholes or how to make the materials that go into new installations, whether that's, say, for example, the light at an intersection or the tubing and their piping that is used to transport water into your home. There are chemists who think about making medical devices or pharmaceuticals. So I imagine there are no small number of chemists working on the COVID-19 vaccine as we speak, either in the direct manufacture or in the research and development. There are chemists who think about food safety. So someone who thinks about the entire system from when food is grown and the chemistry of the soil, all the way through its packaging and delivery. One of the really cool things about being a chemist is that it's all around you. The part of chemistry that I appreciate the most is that you can study science at a macro level or a micro level, and chemistry informs all of it.
You know, I've had a friend that was majoring in chemistry, and so in my head, I'm like, well, what do you plan on doing with that other than like being a teacher? I never realized that chemistry was so applicable in every different area in life. Another question then too is, how much math do you need for chemistry? Or does that kind of depend on your position too and what you're doing every day?
Math is such an awesome way of thinking about the world that I think math is going to inform anything that you do in a meaningful way. For chemists, for example, if you are studying the acidity or basicity of something, you're going to want to be able to use logarithms. If, say, for example, you are thinking about the energy of a system, then you're going to need to use algebra to be able to rearrange and isolate maybe a variable that you're solving for, like enthalpy or entropy. There is calculus that you can do in terms of modeling the behavior of systems. If you have a favorite kind of math that you really love, then there's typically chemistry that thinks about that math and applies it to practical situation.
That's awesome. I think that's a great way to look at it, because I feel math might not be the strong suit for a lot of people. So when they hear it, they're kind of intimidated. But when you put it in the perspective of using it as a tool to see different functions of the world, that's a really awesome way to look at it.
Well, and you know what? I think about this all the time too, because I don't know that math was necessarily ever a strong suit of mine. But I feel like what chemists do and practice every day is a growth mindset. So I believe that I can learn, just like if you were learning to drive a car or learning to play a musical instrument, with practice and feedback. I think that that's one of the ways that you can actually improve your use of that tool. It is not necessarily your innate gift that makes it possible for you to use that in your research, but more importantly, your willingness to grow and learn and improve.
So when did you know that chemistry was what you wanted to do?
That's such a great question. You know what? I actually think I discovered chemistry pretty late in life, that it probably wasn't until college where I took lower division science courses where I made a decision that chemistry was what I wanted to study. And actually, it was something that I really struggled with. And so I think I had a little bit of an identity crisis when I went to college, and wondering whether or not I was smart enough or whether or not I belonged there. And so it was actually through the struggle that I came to appreciate it and really develop a passion for it. And I think that was actually largely due to teachers that I had, teachers who were patient and willing to help me develop different perspectives for learning how to approach problems. And the really cool part is, right, like hopefully what we do is we pass it forward. I had a really phenomenal mentor who said, my job is to make sure that my ceiling is your floor. So the things that we struggle with ourselves, we want to find ways to make those accessible for other people so that where they start is much further along the path than where we did.
Talking about kind of the progression and hoping that whatever comes next has a better kind of setup. What's some of the hardest problems in chemistry that everyone's trying to solve right now?
Well, I think there are some pretty profound ones. There are what we think of as grand challenges. Some of those relate to things like climate change. There are chemists literally around the world thinking about how to address carbon dioxide emissions. There are chemists thinking about medicine and other types of interventions for diseases. There are also chemists who are tackling challenges like fresh water that is safe for everyone to use and drink. And then I think there are some really cool frontiers too. There are issues, say, for example, of pH in terms of ocean acidification. There are opportunities for chemistry in space. and space exploration. So I think there are some really phenomenal frontiers that are available to anyone, I think, who's interested in solving problems. And they're significant problems, so we need everyone's help.
What do you think are some of the major setbacks that prevent advancements in coming to solutions for those problems?
Some of it is communication. I think that sometimes we have research areas that can be siloed, whether that's because of just a lack of understanding of who's doing what or in a lack of awareness. Another opportunity, I think, to grow and change and improve the process has to do with diversity of perspective. So one of the reasons why we want a diverse representation within science is because everyone's coming from a different prior experience, different prior knowledge, even different approaches in terms of how we view and think about problems. If we're only looking at a problem one way and not adopting other perspectives, one of the things that I've really appreciated about working in the CSUMB community is the community of practice, or the colleagues that I work with. I actually value the fact that folks look and think about things differently. That informs my own practice as a teacher and as a researcher and as a scientist. If the barrier is getting folks from diverse perspectives into the field, then invariably it's going to be less than it could be if it had those other perspectives.
Definitely. And so then that kind of comes full circle again too, with making sure that your students that you teach, you pay it forward and that they have, the confidence in their own capabilities. And that's what I really love about this internship I'm doing too, and having the opportunity to talk to you and then to present this information to kids and to show them that no matter what your background is, anything that you're interested in doing and you want to do, you can do it. And you can have these questions, and all of your thoughts and your information and your perspectives are valuable in the community. So that's really important, I think, to put out there and to encourage, is that collaboration of ideas.
I agree. I think the more we can create a community that way, where everyone's welcome, regardless of what your prior knowledge or training is, sometimes the most brilliant ideas come from someone who's thinking about it in a different way.
With that being said, I have a question that was actually submitted from a kid for a chemistry teacher.
I'm Joey, I'm 8 years old, and my question is, why when you bake a cake or cookies or something, it turns from a liquid to a solid?
Ooh, that's such a great question. Okay, so some of it depends upon the ingredients, but one of the things you're going to notice is that most cakes, almost all, have some type of leavening agent in them. And so what ends up happening is that through the baking process, there are gases that expand, and those gases spread heat and extend heat. And so that's part of the reason why sometimes you see bubbles or air pockets in cake. And then the liquid transforming to a solid actually has to do with a couple of components. So there are binders usually, sometimes eggs are binders in the recipes for cake. And so that binder helps to connect things like flour or sugar, maybe cocoa. And so the ingredients that are going into your mixture are both solid and liquid, right? So your flour is a solid, or your sugar is a solid. And so the starches that are present, so these are long chains of sugars that are in your flour, can undergo a process they call gelatinization. So that's where they absorb water. And that is actually what causes the batter to set from a liquid to a solid. I think another piece that might be worth thinking about is, when you mix cake batter together, one of the things you're doing is incorporating all of those ingredients together. And so you can also have proteins that with heat or acid or salt can relax and denature and then reform into another shape. And so that's another reason why, if you're adding eggs to your mixture, that can also cause your batter to set. But I actually think that for a lot of cases, it's mostly the interaction between the water and the heat in a mixture. You try and make a cake several different ways to see what kind of a solid you form. That would be a great experiment to run. You can choose lots of different variables to explore.
Okay, so last question we got here is, what is the best part about your job?
People are the best part about my job. I think that that's one of the coolest parts about science, is that You get to learn from each other and collaborate together. People help expand my sense of wonder, and asking questions and trying to make sense of the world is something that is a joy every day.
Alrighty, well, that was all the questions that I have. Again, thank you so much for taking the time to
marvelous.
do the interview with me. It's been an absolute pleasure.
Awesome. Well, it has been my pleasure too. I'm thankful for the opportunity and look forward to our next conversation. All right, we'll see you in the not so distant future. Take care.